For the next part of your project, you're going to work on some new methods that will help to work toward being able to do some of the game logic and some of the game execution, in particular doing part of the player turn. That part will be a single sow, which is where a player can take the seeds from the selected pit and drop one at a time in the following pits counterclockwise from there. So if they selected this pit, then they would drop one here, one here, one here, and one here. That's only part of the player turn. In the next part of the project, you'll have to complete the player turn, which involves relay sowing, where the turn keeps going if the pit that they landed in last was not empty. But for now, we'll only work toward a single sow and some of the helper methods that will work on this logic for the game. So the methods shown are the ones that you'll work on. The first of them, that's the most helpful for all the others, is being able to take a pit label and turn it into coordinates, because if you recall, all of your pits are in a 2D array. A label like A, B, C, or D doesn't really help you look things up in that 2D array. You need rows and columns. And so that's what that method will do. Then you can see all of the following methods use the pit labels as their input to be able to do things like find the opposite pit in the other player's row, check whether a pit is in the current player's row, get the next pit in that counterclockwise sequence we talked about, or get the pit's seed count for the particular pit that was given, and then to do that single sow where you pick up seeds and drop them in the other pits. All of these take a pit label because the player shouldn't have to be inputting 0, 1, or different row column values. So I've set things up with some tests here for each of these methods, and we'll look first at pit 2 coordinates. When we run the code, we can see that it displays part of the board, or displays the board as an example here, and then shows the coordinates for a few different pits. You can test this out for as many as you'd like. A will always be your first pit, and it should always have the coordinates 0, 0, because it's the first entry, the first column in the first row. J in this example is in the second row, and it's the fourth item there, so its coordinates are 1, 3, and then L is our very last pit in the board that's shown here. Its coordinates are 1, 5. These will change if your board size changes, so it's important to write your method to be general to work for any size board. Once you've got those coordinates, then you can start to work toward some of the other methods that are available or that are required here. For example, being able to get the opposing pit will be helpful in some of the later game logic for the next part, so that if the player lands in pit A, you're able to see, for instance, whether they capture seeds across in the other row in pit G. If the selected pit is J, then the opposing pit will be up in the first row, D, and then likewise for L, the opposing pit will be in the first player's row, and it would be F. So again, I would test this with a large number of values and make sure that it works on any number of different sizes and types of board. The other one that will be fairly challenging sometimes is to be able to get the next pit, because this doesn't follow our typical 2D array order. We won't go from 0, 0 to 0, 1 to 0, 2, etc. We will go in counterclockwise order, which means that, for instance, A, the next pit would be G. We go against the direction a clock would go. From J, we are moving down that row, which is a little more standard order, to K. From L, we then move up to F. If we were, for instance, on F, the next pit reported would be E. It's moving backwards in the first row and forwards in the second row to make that counterclockwise ordering. The next method that I've tested is pit in player row. And again, this will be helpful for some of the later game logic. I've only run this for a couple of pits. You could test it for lots of them. The main thing that I've tested is row C is in player 1's row, and so it should report true in that case. Row C is not in player 2's row, and so it should report false. You can test this for lots of different locations, and I would advise you that you do. Then, the biggest step, as I said, was to be able to perform a single sew. So, this will take a little bit of examination. When we sew from a pit, it's actually going to change the board. So we've seen the original board where every pit has 4 items in it, has 4 seeds in it. If we sew from G in this example, it moves counterclockwise, so down this row, and you can see that the 4 following pits have gained 1 seed, and G has none now. Then those changes persist, which is important for the game to be able to keep moving. Remember, when a 2D array or any array is passed to a method, like how we pass our pits into the method single sew, changes made to that array will stay put. They will be reflected in the original array. So now if we sew from A, we can see that it took the 4 from A and it put 1 in G, 1 more in H, I, and J, and then it stopped there because it ran out. If we sew from D now, we have 5 in C, 5 in B, and A gets 1 again. G has accumulated 2, and then it didn't go any further. It only had 4 of them to work with. So you could test this for lots of different values. There's one method I've left untested right now. It's probably the simplest one to write after you've written the one that gives you coordinates, and that is get pit seed count. The reason I didn't test it until now is because all of the seed counts were the same at the start, and so it would be reporting 4 for everything. So now we'll test it at the end, and it'll give us a little more interesting values. So we can check against that last board that was given. Pit A has 1 seed in it. That's correctly reported. Pit J has 6 seeds in it. And Pit L has its original 4 seeds in it. So while you're working on the methods for this part of the project, one piece of advice would be to stop and think at all times about how those methods fit into the game rules and how they're going to help you in implementing the final game. But remember in general for this one that your first task is to be able to turn a pit into coordinates so that players can use these convenient labels rather than our 2D array coordinates, and inside your code you can then use those coordinates to do the other tasks that you have required of you there once you've been given those pit labels. And the final task that's going to require some of the other methods to be done will be performing that single sew.